we talked about these three basic fundamental properties. Now, why are they useful? How could you use them in practice? And here's a simple sort of anecdotal example of trying to apply the laws. So I'm building a search engine. Suppose I wrote a crawler and I gathered about 200 gigs of English web pages. So without knowing anything else, can I figure out any statistics? Can I figure out anything about that collection of text before I even started counting anything? And yes, I can, right? So I called about 200 gigs. So if I assume that the length of the average word in the English language is about 10 characters, including once you cut off whatever spacing and punctuation was around the words, yeah, fair assumption. So I would have about 20 billion distinct words. So from Heap's law, I can figure out that, okay, about 35 million of them are going to be unique. Now that's assuming that parameters that I had from my previous crawl apply to this new crawl, which might not always happen. But if they do, then I have a pretty good prediction of how many distinct terms I'm going to have. And since I'm building a search engine, that's how many index entries my engine is going to have. Now, out of those 35 million terms, what I know by Zipf's law is that about 17 million of them will only occur once. Why is that? From Zipf's law, if you look at the x-axis of the Zipf's law, the right half of the x-axis is all the words that occur only once. So about half the words will occur only once, and the will have an obscenely high frequency. And I guess, so for clumping, we didn't give exact formulas, so, but basically you can use models of clumping to figure out how often you expect relatively rare words to have certain high frequencies in an individual document.